All right, we're talking about the volume of a cone on this video. And if you haven't already, take a moment to pause this video and watch this other video, which will be very helpful in understanding what we're talking about. But some of you might think, well, the volume of a cone, that's got a pointy end and it's got a rounded bottom. This is going to be really challenging. But it turns out it's not as bad as you think. So if you watch the video, you'll see that they do a little experiment where they take a cone that has the same sized base as an accompanying cylinder and is also the same height of that cylinder, that it takes 3 of these cones to fill up a cylinder with the same dimensions. And by that, we found out that the formula for the volume of a cylinder then is just the same thing for the volume of a cylinder divided by 3, because it takes 3 cones to fill up 1 cylinder. So pi r squared times the height divided by 3. So let's get right into it and let's see how this works then. So for our first one, we're going to do 3.14 times the radius, which in this cylinder is 6 squared. And then the height, as you can see, is this amount right here. That's 15. And then when we get done with all that, we're going to divide by 3. So this is the volume of this cone. Now I have a calculator that I'm calling up. I don't believe that you can see it, but I am taking a moment to calculate that, and I'll just kind of verbalize that. So if you have a calculator of your own, you can do that as well. So 3.14 times 6 squared times 15 equals, and then I divide that total by 3, and so my final volume on this particular cone is 562.2. So 562.2, and our units are centimeters cubed. Hey, that don't look too bad, does it? Okay, let's try another one. So our volume of this cone then, let's go ahead and use a green color since the cone is kind of a green color. The volume equals 3.14 times the radius, which is half of this diameter here, so times 2 squared, times the height, which is 6, then divide all of that by 3. Now I want to throw a caution out there. Some of you may notice that if this is the radius squared equals 4 in this case, which is the same as the diameter, that doesn't work out for every cone, only for ones that have a radius of 2. So don't get in the habit of just thinking that this diameter is radius squared. Okay, here we go. So get our calculator. You do your calculator. 3.14 times 2 squared times 6, and then I'm going to hit equal. So I've calculated the entire top right here. And then I'm going to divide that by 3. So divide by 3, and I end up with a number of 25.12. So V equals 25.12 meters cubed. Now it's not telling us to round it at this point, so and we didn't need to round it because it only went out to hundredths. Okay, here's another cone. So the volume of this cone, if we're going to use purple since we got a purple cone. So remember our formula, 3.14 times the radius, which in this case is 2, times the height, which in this case is 4, And then when we get all done, we'll divide our total by 3. So when we get doing our calculating, we have 3.14 times 2 squared times 4, and that equals 50.24. And then when we divide that by 3, we get 16.7. We're going to just round it to 16.7. That's about where it comes out to be if you round it to the nearest tenth, and that would be inches cubed. Okay, very good. All right, this cone's a little wider, it's, short little cone, but it's kind of got a nice wide base to it. And if the diameter is 6, then that means the radius of the base is going to be 3, which is the number we need to use up here. So volume of this cone is 3.14 times the radius, 3 squared, times the height, which is 3, all divided by 3. Well, if we go ahead and multiply all of that out and then divide by 3, what do we get? Now, some of you might notice that I've got a 3 on top and a 3 on the bottom. I can cancel those out and just do 3.14 times 3 squared. And you can do that, but I'm going to just go ahead and multiply it all out, make sure I didn't miss anything. So 3.14 times 3 squared times 3 equals, so that's 84.78. 84.78 divided by 3 gives me 28.26. So volume equals 28.26 meters cubed. All right, so that's a little bit of, if you think about how big a meter is, that if that cone was real, this would have a lot of fluid in it, wouldn't it? Or whatever it is. Okay, now we're going to get into a couple of story problems. So a company uses paper cups shaped like cones for its water cooler. Each cup has a height of 10 and a base that has a diameter of 12. So to look at our picture of this, here's our cup. Some of you drinking out of these cups, sometimes it's kind of hard to keep from squishing the water out of them if you're not careful. So the height of this whole thing is 10 centimeters. And then the diameter of the cup all the way across is 12 centimeters. So now we're going to find the volume. So volume equals 3.14 times 6 squared, because if it has a diameter of 12, then radius is 6, right? So pi r squared times the height, which is 10. And so here we go, calculator. 3.14 times 6 squared times 10, and that equals 1130.4. And now we're going to divide that by 3. So we end up with 376.8. So there's the volume of a cup, right? Now we've got this much water in there, so let's figure out how many cups we can fill with that much water. So we're going to divide this number by that number. So here we go. Calculator, 16956 divided by 376.8. And that comes out to be 45 cups. All right, so if you have one of those water coolers, you could get 45 cups out of it. Doesn't sound like a lot, but I guess that's still quite a bit if you have kind of a small office crew using this cooler. Okay, here's another one. A sculpture is made of solid tin in the shape of a cone. The sculpture is 70 inches tall, and its base has a radius of 9. And tin costs $1.75 per cubic inch. How much did it cost for the tin for the sculpture? Well, first of all, we got to find the volume of this cone. So the volume is equal to 3.14 pi times the radius squared, and that's 9 squared, times 70, all divided by 3. Then when we get done, we'll have a number that we will multiply by 1.75 to get our total cost. So let's take a look again real quick. Get our calculator. If you're doing it at home, do it. 3.14 times 9 times 9 times 70 equals 17,803.8. And then divide that by 3, and it's 5,934. 5,934.6. All right, so that's how much it takes to make one sculpture. Now we're going to times that by $1.75. So $1.75 times all of that. So we have a calculator. 1.75 times 5,934.6 equals 10,000 $10,385.55. That's an expensive sculpture, isn't it? That better be used for something pretty cool, because that is a lot of money. All right. So as you can see, these volumes are easy to find, and then once you get a volume, then you can actually find cost. You can find how long it'll take to fill or drain something like that. So it's a lot of fun. Okay, we got one more here. A truck company needs to move a pile of limestone. So here's a big pile of rocks. The limestone is stored in a pile shaped like a cone. The pile is 13 yards high. So the height of this pile is 13. And at the base, the radius is 9 yards. So how many truckloads will the company need if each truck holds 7.02 cubic yards? So first, let's find the volume of the pile. So that's going to be 3.14 times 9 squared times 13. And then when we get done, we'll divide all of that by 3, all right? So let's get that number first. So using our calculator, 3.14. Hopefully you're doing this on your calculator at home or calculator at school if you're watching this at school, times 9 squared times 13, which gives me 3,306.42, which when I divide by 3, I get 1,102, and the decimal on that is 0.14. Okay, now all we have to do is, how many truckloads will the company need if each truck holds this much limestone? So we're going to divide this total by 7.02. So let's see if we still have that total on our calculator. We do. So now we divide by 7.02. That equals 157 truckloads. Now you might want to think about that for a minute. Sometimes truck drivers charge by the load, and if that price is a little bit up there, this could cost you a lot of money to move this pile of limestone. All right, now we could see a problem on Alex that might look like this. So a cylinder and a cone shown above have a congruent base and equal heights. So we know that the volume of the cylinder, let's find the volume of the cylinder. So the volume of the cylinder is 3.14 times the radius squared, which will be 7.5 squared times the height. So using my calculator, that's going to be 3.14 times 7.5 times 7.5 times 5. So that's 883.125. So 883.125 centimeters cubed. So the volume of the cone, then, if I divide by 3, divide that first number by 3, I get 294.375. Okay, so we know that the volume of the cylinder equals 3 times the volume of the cone. So what do you think? Is this equation true for all cylinders and cones, or for all cylinders and cones with congruent bases or equal heights, or is this equation true only for cylinders and cones shown above? Well, it turns out, as we discussed in our earlier lessons, that this is true for all cylinders and cones that have the same size base and the same height. That's the key. And if you notice in there, these pictures show same base and the same height. Okay, so your assignment is actually not going to be number 61. What number was that? It's going to be 105, if I'm not mistaken. 105. So check that out, and good luck. Thank you very much.